Welcome. In this short tutorial, we shall learn about the stress-strain graph. A stress-strain curve is a graphical way to show the reaction of a material when a load is applied. It shows a comparison between the stress and strain by gradually applying load to a test material and measuring the deformation of the material, which can be useful to determine the Young's modulus, yield strength, and the ultimate tensile strength of a material. Let us begin with defining the stress and strain. Stress is defined as the force experienced by the object which causes a change in the object, while strain is defined as the change in the shape of an object when stress is applied. Stress is a measurable quantity and has a unit, while strain is a dimensionless quantity and has no unit. Young's modulus, or the modulus of elasticity, is the mechanical property of the material that measures the tensile stiffness of a solid material. It quantifies the relationship between the tensile stress and the axial strain. It is determined by the slope of the stress-strain curve. Proportional limit determines the greatest stress, that is directly proportional to strain, whereas material's elastic limit is the greatest stress that can be applied to it without causing plastic deformation. When material is stressed to a point below its elastic limit, it will return to its original length once the stress is removed. The fracture point, on the other hand, is the point of strain, where the material physically separates. At this point, the strain reaches its maximum value and the material actually fractures, even though the corresponding stress may be less than the ultimate strength at this point. The resiliency of a material is defined as the maximum energy that can be absorbed by unit volume without creating permanent distortion. It can be calculated by integrating the stress-strain curve from zero to elastic limit. Formability is the ability of a given metal to undergo plastic deformation without being damaged. The plastic deformation capacity of a metallic material is represented by the area below the yield strength and the fracture point. Toughness of a material is the ability of a material to absorb energy before it fractures. It represents the total area under the stress-strain graph. So in this presentation, we have seen what actually is a stress-strain graph,